Hi everyone, welcome to my channel Java Interview Revision. In this video, we will revise some concepts like JVM architecture and key enhancements introduced in Java 8 and later. Let's begin with the first question. What is difference between JDK, JRE and JVM? So JDK provides all tools needed to develop the Java program. JRE, it gives environment to run those programs. And the JVM is the engine that executes Java bytecode. In short, JDK is equal to JRE plus tools and JVM is the runtime engine inside JRE. Next is JVM architecture. So this is the architecture diagram of JVM. It takes the compiled .class file, loads into the memory, manages memory, executes code, and interacts with the operating system. So this makes Java truly platform independent. There are four major components of a JVM. First is class loader system, which loads the .class files from class path into the memory. Second is runtime data areas, which stores data while program runs. Next is execution engine, which executes the bytecode. Last is native interface plus libraries, which connects with the operating system. Let's see each one of the component in depth. First is the class loading, which includes three steps: loading, linking, and initialization. Loading means it loads the .class files from class path into the memory. Linking prepares the loaded classes. There are three steps included in linking: verification, preparation, and resolution. It checks the bytecode safety, then allocates the memory for static variables, and then replaces symbolic references with actual references. Last one is initialization. It executes static blocks and assigns values to them. There are several types of class loaders in Java. 1. Bootstrap class loader. It loads the core Java classes like java.lang and java.util. Second is extension class loader, which loads extension libraries. Next is system or application class loader, which loads the classes written by user. We can also create our custom class loaders to handle special loading needs. For example, reading encrypted class files. Next component of a JVM is a runtime data areas. Inside that, we have few sections. It is a method area. Method area stores class information and static data. Another is heap, which stores objects which is created using the new keyword. Another is a Java stack, which holds the method calls and local variables. Next is PC register. It tracks which instruction is currently executing. Next is native method stack, which supports non-Java code like C, C++ code. Next component of a JVM is execution engine. Execution engine is the heart of a JVM. This is where the actual execution of bytecode happens. The interpreter reads and executes bytecode line by line, allowing programs to start quickly, though it can be slower later. The just-in-time compiler improves the performance by converting frequently executed bytecode into machine code, so it runs faster on subsequent executions. Next is the garbage collector, which automatically removes unused objects from memory, freeing up space and helping application run efficiently. Next question is, what is the difference between heap and stack memory? The heap is used to store objects and lives until garbage collection removes the unused objects. It's generally slower because it needs to manage dynamic memory. On the other hand, stack is there. Stack stores method calls and local variables. It is very fast but temporary. When a method finishes, its stack memory is cleared automatically. In case of a thread access, heap memory is shared by all threads. But in stack, each thread has its own stack. Next question is, what is garbage collection and type of garbage collections? So garbage collection is one of the Java's biggest strengths. It automatically identifies and removes objects that are no longer used to freeing the memory space without manual intervention. There are several types of garbage collectors. One is serial JC, which is simple and uses a single thread. Other one is parallel JC, which uses multiple threads for faster cleanup. The G1 JC, which divides the heap into regions and manages memory efficiently for large applications. Next is ZGC, which is a modern low latency options that keeps pause times extremely short, even for large heaps. This automation helps Java programs run smoothly without memory leaks. Next question is, what is metaspace in JVM and what are its benefits? So metaspace is a memory area introduced in Java 8 to store class metadata. It resides in native memory instead of a heap, which grows dynamically. Before Java 8, PermChain was used to store class metadata, but it had a fixed size limit. So what are the benefits of a metaspace? Like, it has no fixed limit. It reduces chances of getting out of memory error. It gives faster and more flexible memory management, and it supports automatic class unloading. Next is, why should developers understand JVM internals? So understanding JVM internals helps the developer identify and fix memory leaks. It improves the performance and they can write more efficient code. So interviewer often checks your JVM knowledge to see if you understand what happens behind the scene when you run the Java code. So this is all about the JVM interview questions and answers. Thanks for watching. Please like and subscribe my channel if you want to see more content like this. Thank you.